Hello dear students, welcome back to this course of Artificial Intelligence. I am your course instructor Krishna Chaitanya Nagaraju, Assistant Professor in the Department of Computer Science Engineering, GRIT Hyderabad. From this session onwards, we will discuss Unit 2 of this course, Knowledge and Reasoning. Here today we will discuss knowledge-based agents, introduction about these things. Let us go. Now, the learning objectives for these sessions would be to provide an overview of existing representational frameworks developed within AI, their key concepts and inference methods. And another objective is to acquiring skills in representing knowledge. And we also would like to have an objective of understanding the structure of knowledge-based agent. The learning outcomes that are expected are understanding the principles behind different knowledge representation techniques, comprehend the role of knowledge base, understand basic structure of knowledge based agent. So the basic question is, what is knowledge? Let us try to understand this based on the definition we can find in the dictionaries. Knowledge can be seen as an awareness or familiarity gained by experience of a fact or situation. Whatever you might be coming across, a fact or a situation, what experience you gain, that can be considered as a knowledge. When you look at the Wikipedia, you will find something like this. The words of Richard Rorty: the eventual demarcation of philosophy from science was made possible by the notion that philosophy's core was theory of knowledge. As we know, AI has drawn basics from different sources. One of the core subject is philosophy, and the philosophy's core was theory of knowledge. A theory distinct from the sciences because it was their foundation. Without this idea of a theory of knowledge, it is hard to imagine that what philosophy could have been in the age of modern science. So, as far as Plato is concerned, the classical definition described specifies that a statement must meet three criteria in order to be considered knowledge. Anything, any statement should be, it must be justified, it must be true and believed. Then we can consider it as a knowledge. Now, we can find this Bellinger's 1980 knowledge model, which specifies, the general raw data you have got, and if you can understand the relation between the raw data, that means you have some information. When you can understand the patterns, you will get knowledge. If you can understand the principles behind the patterns, then you have wisdom. This is how it can be shown in the degree of connectedness from data to wisdom. Okay, on the degree of understanding. The model tells that as the degree of connectedness and understanding increase, we progress from data through information and knowledge to wisdom. Now, as per John McCarthy, logical AI is, the idea is that an agent can represent knowledge of its world, its goals, and the current situation by sentences in logic. Now we need to understand how to create these sentences in logic, that we will discuss in these sessions, and decide what to do by inferring that a certain action or course of action is appropriate to achieve its goal. So based on the sentences, what it is having, we call it as knowledge base, it should be able to decide. Decision is to be made by inferring that a certain action or course of action is appropriate. In the early days of AI, more focus was given on creating knowledge bases, on the development of agents which can interact with those knowledge bases. They are termed as expert systems. We did discuss certain example expert systems at the beginning of AI history. Mycin. It was based on backward chaining and could identify various bacteria that could cause acute infections. If you remember, another one, Dendron, used for chemical analysis to predict molecular structure. Also, we have Pixdes, used to predict the degree and type of lung cancer. There are more example expert systems also. Now, what an expert system generally consists of? If you look at it, there would be an expert person who is having some knowledge on certain domain, and we need someone who can extract the knowledge from this expert person. Again, he could be a person, one more person, a knowledge extractor. Now, based on the knowledge that has been extracted, he or she tries to develop the knowledge base. So, the knowledge is represented in the form of knowledge base. And then, to understand this knowledge base, the crux of the expert system is inference engine, which acts like a heart of the expert system. To have the interaction with the knowledge system, expert system, we need a user interface. Ultimately, an end user interacts with the user, making use of this user interface with the expert system. End user need not to be a technical person. So this is so. Now our concentration is on developing this knowledge base. How we can represent the extracted knowledge into this knowledge base. Now take the example of Wikipedia, another knowledge base what we can have. Huge knowledge base of information describing semantic relationships among different entities you can find here. And then if you are working in the area of natural language processing, you can also find WordNet. Example knowledge base in case of natural language processing. And the question arises now is, how can we build agents that can interact with knowledge base, update its knowledge base, and that can make complex decisions based on inferred knowledge from the knowledge they have. So we wish to create ultimately an agent that is not just reflexive, but to have an internal state of knowledge, update its knowledge based on observations it makes, apply some reasoning on that knowledge, and then take an action. In the sense, what basically we are looking at is knowledge-based agents. A knowledge-based agent can be seen like this, having high level of intelligence with logic. So we need to discuss on logic. The reflex agent is simple low-level intelligence. This particular unit introduces knowledge-based agent, the representation of knowledge, and the reasoning process that brings knowledge to life. Knowledge and reasoning are also important for artificial agents because they enable successful behaviors that would be very hard to achieve otherwise. Now take an example of a chess program. It can calculate the legal moves of its king, but does not know in any useful sense that no piece can be on two different squares at the same time. Now you can clearly say that because you are listening to my session now, you are not there in some theater watching a movie, because at a time you cannot be at two places. So that is the logic what we may need to have. Knowledge and reasoning also play a crucial role in dealing with partially observable environments. Understanding natural language also requires inferring hidden state, namely the intention of the speaker. This is a very big happening area. A lot of research is happening in this. Now take an example. When we hear, John saw the diamond through the window and coveted it. Now what do we understand with this sentence? John saw the diamond through the window and coveted it. We know here it refers to the diamond and not the window. We reason perhaps unconsciously with our knowledge of relative value. Diamond is more valuable, so coveting is done for the diamond. Now take another example. When we hear John threw the brick through the window and broke it. John threw the brick through the window and broke it. What is broken? Window. Again here we are applying the knowledge of relative value. Problem-solving agents have difficulty with this kind of ambiguity because their representation of contingency problem is inherently exponential. So this ambiguity need to be handled. Our final reason for studying knowledge-based agents is their flexibility. It can be extended. They are able to accept new tasks in the form of explicitly described goals. They can achieve competence quickly by being told or learning new knowledge about the environment. And they can adapt to changes in the environment by updating the relevant knowledge. Knowledge and reasoning also plays a crucial role in dealing with partially observable environments. A knowledge-based agent can combine general knowledge with current percepts to infer hidden aspects of the current state prior to selecting actions. We reason perhaps unconsciously with our knowledge of relative value. Reasoning allows us to cope with the virtually infinite variety of occurrences using a finite store of common sense knowledge. The knowledge of logical agents is always definite. Each proposition is either true or false in the world, although the agent may be agnostic about some propositions. Logic has the pedagogical advantage of being a simple example of a representation for knowledge-based agent. But logic has some more certain limitations, severe limitations. Clearly, a large portion of the reasoning carried out by humans and other agents in partially observable environments depends on handling knowledge that is uncertain. The whole world is uncertain. So logic cannot represent this uncertainty well. Knowledge bases. If you look at the knowledge base, we have inference engine, knowledge base. Knowledge base is domain specific content. Inference engine is domain independent algorithms. If you are developing a knowledge base for the chess, then it will have all the rules associated with chess. That means domain specific content. Knowledge base is set of sentences in a formal language. Declarative approach to build an agent or other system, like tell it what it needs to do. This tell is an important thing here. Then it can ask itself what to do. Answers should follow from the knowledge base. Agents can be viewed at the knowledge level, that is what they know, regardless of how implemented. Or at the implementation level, that means we will be considering how it has been implemented. Data structures in knowledge base and algorithms that manipulate them. So an architecture of a knowledge base agent can be at knowledge level. Take an example of a taxi driver. A taxi agent might be knowing that the Golden Gate Bridge connects San Francisco with the Marin County. Now this is just knowing the information, knowledge level. At logical level, he tries to encode this into sentences like links, Golden Gate Bridge, San Francisco, Marin County. Now, at the implementation level, the same sentence can be written in some programming language like Prolog or Lisp. The physical representation of the sentences in the logical level. This includes links, Golden Gate Bridge, San Francisco, Marin County.